Hello students, welcome back in chemistry. In structure of atom, the chapter in chemistry we have discussed about the various energy states. Now we discuss about the hydrogen spectrum. In hydrogen spectrum we discuss the line spectrum. Okay, hydrogen, there are different orbital in an atom of hydrogen. If electron jump from lower orbital to higher energy orbital, then absorption of energy take place, and if electron jump from higher state to lower state, then emission of energy take place, or emission of light will take place, or emission spectra will take place. That spectra is known as line spectra. Difference between the two energy level, that is equal to E1 minus E2, is directly proportional to Heisenberg constant, that is RH. Its value RH is equal to 2.18 into 10 raised to minus 18. Here 2.18 multiplied by 10 raised to minus 18. And the difference between the orbital, where n is the principal quantum number. Here delta E is equal to RH into 1 upon Ni square minus 1 upon Nf square. Ni, that is the initial state from which the electron jumps and goes to final state. Final state means Nf, that is equal to final state. Here delta E is equal to 2.18 into 10 raised to 18 into 1 upon Ni square minus 1 upon Nf square. But as previous we have discussed, that energy is equal to h mu. So this is nothing but is equal to h mu. 2.18 into 10 raised to minus 18. If you divide by this h, cancel this h, divide by this h value, 1 upon Ni square minus 1 upon Nf square. Okay, where h is equal to Planck constant. Where h is equal to Planck. Okay, where h, that is equal to Planck constant. His value is 6.626 multiplied by 10 raised to minus 34. So if you put this value, 2.18 into 10 raised to minus 18 upon h, that is value is 6.626 into 10 raised to minus 34 into same 1 upon Ni square minus 1 upon Nf square. Then mu, that is frequency, it is coming 3.29 multiplied by 10 raised to 15 into bracket 1 upon Ni square minus 1 upon Nf square. So this is equation number 2. This is first one, equation number 1. Again I revise equation number 1, that is delta, change in the energy, 2.18 Heisenberg constant into 10 raised to minus 18 into 1 upon Nf square. But if it is frequency, then its value will change, that is 3.29 into 10 raised to 15. Now we know that frequency is equal to c by lambda. Value of c, that is the velocity of light. If you put this value, that is c by lambda in this, then mu is equal to c by lambda is equal to this. So 1 by lambda if you want to find, and you divide by this c value, then you will get the 1 by lambda. But 1 by lambda is equal to v bar or mu bar, that is equal to wave number. Wave number means number of wave passing through a fixed point, that is known as wave number. So if you want to find the third equation related with wave number, then 1 by lambda is equal to v bar is equal to 1.09 multiplied by 10 raised to 7 into 1 upon Ni square minus 1 upon Nf square. So that is equation number 3rd. So we have 3 equations. You have to remember this number. Okay, this value 1.18. If energy is there, then 1.18. If frequency is there, to 3.29 into 10 raised to 15. If wave number or wavelength 1 upon lambda is there, then you have to remember this number 1.09 into 10 raised to 7 into say the difference in the n number. From this you can find the energy as well as frequency, wave number, okay, and wavelength. So we will discuss the few sum related with this, and we get the idea that what will be the energy comes when electron jump from one orbital to another orbital. Okay. Second topic, that is dual behavior of matter. Matter has dual behavior, that is particle nature and wave nature. We have discussed that energy is equal to h mu. This is related with the wave nature. It is equal to E is equal to Sc by lambda. Second, if it is particle nature, then energy, its kinetic energy is equal to half mv square plus potential energy. Again it is half mv square. If you combine this both equation, okay, particle nature, kinetic energy and potential, kinetic energy plus potential, and that is equal to total energy. If you combine this both energy, then lambda is equal to h upon mv, or lambda is equal to h by p, where p is the momentum. We can also write lambda is equal to m delta v. Delta means change in velocity. If mass you multiply with the velocity, then is equal to h into delta p, means change in momentum, where h is a Planck constant, okay, p is equal to momentum, m is equal to mass of electron or mass of particle, and lambda is equal to wavelength. So this equation, lambda is equal to h upon mv or m delta v, that equation is known as de Broglie equation. We can say that if mass is increases, then wavelength decreases. If mass decreases, then wavelength is. For a bigger particle, wavelength is very less, or vibrational is very less. And for smaller particles like electron, its wavelength is more. Okay. In terms of velocity also same. If velocity increases, wavelength decreases. If wavelength decreases, here second equation, its energy is higher. Okay? Or less wavelength, then energy is more. We come to the sum related with dual nature of matter. Okay, sum number 22.12. What will be the wavelength of ball? So we have to find wavelength. So we have to find lambda. What will be the wavelength of ball of mass 0.1 kg? So mass is given 0.1 kg. Moving with the velocity of 10 meter per second. So velocity is given 10 meter per second. We want to find the wavelength. Now we use the de Broglie equation, that lambda is equal to h upon mv, mass into velocity, and this lambda and this Heisenberg constant. So we want to find what will be the wavelength. We put the value 6.626 into 10 raised to minus 34. That is equal to Heisenberg constant value into mass 0.1 kg into velocity, that is 10. So answer will come this 10 into 0.1, then it will be cancelled. 0.1 into 10 means 1. So answer is coming 6.626 into 10 raised to minus 34. Okay, meter. So that is the wavelength in meter. We can convert into nanometer also, but smaller unit. But the meter, it is coming 6.626 into 10 raised to minus 34. Now we discuss sum number 2.14. Calculate the mass of photon with wavelength is given 3.6 angstrom. So first we discuss lambda is given 3.6 angstrom. Mass you have to find. M is equal to question. Okay, here wavelength is given in Armstrong, so we will convert into meter. So which is equal to 3.6 multiplied by 10 raised to minus 8. Okay, 10 raised to minus 8. 10 raised to minus 8 centimeter. If you want to convert into meter, then 3.6 into 10 raised to minus 10. So again we apply lambda is equal to h upon mv. Very good. And we want to find the mass. So m is equal to h upon lambda. Calculate the mass of photon with the velocity. This h value is 6.626 into 10 raised to minus 34. That is Heisenberg constant. Okay. Here v means velocity. Their mass is there, so you can take the velocity of light. Here it is photon, means it is related with the light. So this v is nothing but it is c. 3 multiplied by 10 raised to 8 meter per second. 8 meter per second. So if you put the value, this lambda 3.6 into 10 raised to minus 10 multiplied by 3 multiplied by 10 raised to 8 plus 8. Velocity meter per second. If you solve this, then you will get the mass in kilogram. You will get the mass in kilogram. That is coming 6.135 multiplied by 10 raised to 6.135 multiplied by 10 raised to minus 29 kg. So mass of photon. Photon means electron which emits light. So its weight is very less, coming in 10 raised to minus 29 kilo. Okay. Now we come to the third topic, that is Heisenberg uncertainty principle. Okay, Heisenberg uncertainty principle. Okay, Heisenberg uncertainty principle. It says that it is impossible to find simultaneously the speed and position of moving microscopic particle in space. Microscopic particles means whose weight is very small. So for that particle, it is impossible to find the position. So this delta x is error in position. Position error. And second is the speed or velocity. That is this delta p. Delta p we can write delta x into m delta v. Why? Because it is momentum greater than equal to h upon 4 pi. So m delta v, that is equal to momentum error. So it is difficult to find simultaneously the position as well as speed or momentum of moving microscopic particle in space. Means suppose we want to find the position of microscopic particle whose volume is very small. Then we want to find its position, then we have to use the light whose wavelength is very less. If wavelength is very less of the light, then electron microscope if you use, then its energy is increased. If energy increases, then to find the position of electron, that electron will change its position. So this error is nothing but if wavelength, if you decrease of the source, then it will change the momentum. Second, if you decrease the frequency or lambda of electron microscope, then its vibrational means waves will increases. So its position error will be increased. So two type of error, that is position error. This error delta x, it is related with the frequency. Here frequency if it is less, then position error is less. If wavelength if you increases of the waves to find the position, then its error is more. Again this you make it less to find the point. Suppose of the electron, this point is nothing but electron. We want to find the position. If you use the light source with less energy, then its momentum will change position. Error in the position is less, but momentum error will increase. Again, you decrease that momentum energy, so you use light with less energy, so its wavelength is more. If wavelength is more, then this position error is more as compared to momentum. So if one error is decreases, other error is increases. Okay, and vice versa. So it is difficult to find position as well as momentum of moving microscopic particle in space. So this x is nothing but it is position error, m delta v, that is means change in the velocity. So momentum change, momentum error, and h is equal to Planck constant. Right? H is equal to Planck constant, and that is greater than equal to h upon 4 pi. We discussed one sum related with this, that how we can designate this Heisenberg constant with position and momentum error. Okay, we discussed the sum number 2.15. A microscope using suitable photon is employed to locate an electron in an atom. So we want to find the position of an atom with a distance of 0.1. So error in the position is given. So it is equal to delta x, that is equal to 0.1 angstrom. We convert into meter. So 0.1 multiplied by 10 is to minus 10 meter. We have minus 8 centimeter and minus 10 meter. What will be the uncertainty in measures of velocity? So first we write the Heisenberg delta x into delta p is equal to h upon 4 pi. Delta x into m delta v is equal to h upon 4 pi. Value of h 6.626 into 10 raised to minus 34. This m is nothing but it is the mass of electron or weight of electron. So m is equal to 9.01 into 10 raised to minus 31 kg. Weight of electrons. H value is given this. So from this we can find what will be the uncertainty level. So we want to find delta V. So delta V is equal to h upon 4 pi. This all value comes down, so means delta x into m. H value is 6.626 into 10 raised to minus 34 upon 4 multiplied by 3.14 into delta x, means this value 0.1 multiplied by 10 raised to minus 10, and mass of the electron multiplied by 9.01 into 10 raised to minus 34. So if you solve this, then we will get the delta V value. Okay, delta V value we will get, and that value comes is equal to delta V value, that is equal to 5.79 into 10 raised to 6 meter per second. 5.7 into 10 raised to 6 meter per second, means this much error will come in the velocity, or change in the velocity will observe this, that will alter change in the momentum. So its value delta V is coming this. So uncertainty value is coming this much meter per second, 10 raised to 6, approximate 10 raised to 6 meter per second. Okay. So similarly you try to solve example related with the energy, hydrogen spectrum, okay, de Broglie equation, and this third one, that is Heisenberg uncertainty principle. So these three things we have discussed today. So you try to solve 2 or 3 sum related with each topic from your text. Okay, thank you.